Good day, students and parents! You are watching Valenzuela Facebook Live. Today, we are on our 4th week and we will be discussing Lesson 4. New day, new lessons to learn. Under Lesson 4, we have 2 topics to discuss. The first one is about the properties of operations on the set of integers. And the second one is about changing fraction form to decimal form and vice versa. Furthermore, our learning competencies at the end of this lesson is for you to illustrate the different properties of operations on the set of integers and to express rational numbers from fraction form to decimal form and vice versa. Let us discuss the first one. So, what are these so-called properties of operations on the set of integers? Well, we've got 6 properties on the list. We have closure property, commutative property, associative property, distributive property, identity property, and inverse property. Let us discuss these properties one by one, starting with the closure property. Closure property states that the sum or product of any 2 integers will always be an integer. In a plus b is equal to c, if the addends a and b are integers, then the sum, which is c, is also an integer. Furthermore, in a times b equals c, if the factors a and b are integers, then the product, which is c, is also an integer. Remember these keywords: closed or belongs in a closed group. For example, 2 plus negative 8 is equal to negative 6 is an illustration of closure property. Since the addends 2 and negative 8 are both integers, then the sum, which is negative 6, is also an integer. Simple, right? Let us have this time the second property, which is the commutative property. It states that in addition or multiplication, the order of the terms, specifically the addends or the factors, does not matter. The results will be the same. That for any 2 integers a and b, a plus b is just the same or equal to b plus a. The same thing goes with multiplication. A times b is just equal to b times a. No matter which comes first, the sum or the product will just be the same. Remember these keywords: commute or move around. For example, 12 times negative 5 is equal to negative 5 times 12. No matter what order the factors are, it will not affect the answer. Both will result to negative 60. Get it? Good. Now, let us have the third property, which is the associative property. It states that you can add or multiply integers regardless of how they are grouped. That for any integers a, b, and c, a plus the sum of b and c is just the same or equal to the sum of a and b plus c. Moreover, for multiplication, a times the product of b and c is just equal to the product of a and b times c. No matter what grouping the addends or the factors are, the results will be the same. Remember this keyword: groupings. For example, 4 plus the sum of 16 and 20 is equal to the sum of 4 and 16 plus 20. No matter which two integers are grouped together, it will result to the same answer, which is 40. Now, let us discuss about one of the most commonly used property, the distributive property. This property applies when an integer is being multiplied by the sum or difference of integers. That for any integers a, b, and c, a times the sum of b and c will be equal to a times b plus a times c. Moreover, for subtraction, a times the difference between b and c is just equal to a times b minus a times c. We just multiply the integer outside the parentheses to each integer inside the parentheses. Remember these keywords: distribute, allocate, or give to each one. For example, negative 5 times the sum of 8 and 3 is just equal to writing negative 5 times 8 plus negative 5 times 3. The number outside the parenthesis, which is negative 5, is distributed to each integer inside the parenthesis. That is distributive property. This time, let us have identity property. Identity property states that when an integer is added to 0, it will give the same number. And when an integer is multiplied by 1, the result will be that integer. That is why we call 0 as the additive identity, because any integer a plus 0 will be equal to the same integer, which is a. Furthermore, we call 1 as the multiplicative identity because any integer a multiplied by 1 will result to the same integer, which is a. Remember these keywords: self or sameness. For example, negative 25 plus 0 will just be equal to negative 25. And 100 times 1 will just be equal to 100. That is identity property. And for our last property, we have the inverse property. It states that the sum of an integer and its additive inverse is 0. And the product of an integer and its multiplicative inverse is 1. The additive inverse is the opposite with regards to sign of a number, which simply means that the additive inverse of a positive number is its negative counterpart. And the additive inverse of a negative number is just its positive counterpart. Moreover, the multiplicative inverse is the reciprocal of a number. Remember these keywords: opposite or reverse. For instance, 18 plus negative 18 is equal to 0. That is because they are additive inverses of each other. Furthermore, 4 times 1/4 is equal to 1. That is because they are reciprocals of each other. So, when you add additive inverses or opposites, it will be equal to 0. While when you multiply multiplicative inverses or reciprocals, it will result to 1. That is inverse property. That completes our 6 properties of operations on the set of integers. Let us have a quick check on how much you understand this lesson by answering the following practice questions. All you have to do is to identify what property is illustrated in the following given. For the first one, we have 5 plus 3 equals 8. For circle, it's closure property. For triangle, its commutative property? Is it circle or triangle? Correct. The answer is circle, closure property. Question number 2. 6 times the sum of 2 and 3 is equal to 12 plus 18. For circle, it's associative property. For triangle, distributive property. Is it circle or triangle? The correct answer is triangle, distributive property. Now, for our third question, 5 plus the sum of 7 and 3 is equal to the sum of 5 and 7 plus 3. For circle, it's commutative property. For triangle, associative property. Is it circle or triangle? The correct answer is triangle, associative property. Did you get them all correctly? Great! That concludes the first topic for lesson 4. This time, let us have the second topic, which is about expressing fraction form to decimal form and vice versa. So, how do we change a fraction into a decimal? Do you have any idea? Correct. We are going to use the method of long division. As a short recall, here are the steps that you need to follow in doing long division. First is division, followed by multiplication, then subtraction, and then bring down. To remember it easily, try remembering the first letters of the steps, which will be D, M, S, B, which stands for divide, multiply, subtract, and bring down. I have here some examples to show how it is done. For the first one, express 2/5 into decimal form. So, using long division, we are going to divide the numerator by the denominator. That means the numerator 2 will be the dividend, which will be written inside the division symbol, and 5, which is the denominator, will be the divisor, so it will be written outside the division symbol. Then, we can now start dividing the numerator by the denominator. Since the dividend has a smaller value than the divisor, we are going to put a decimal point after 2 and right above it to preserve its original value. Then, annex or write 0 after the decimal point. So now, we can assume that the dividend is 20. We now have 20 divided by 5 is 4. Then, 4 times 5 is 20. 20 minus 20 is 0, which leaves us now with a remainder of 0. Since there is no number written in the units place, we're just going to write 0 before 4. That makes it 0.4. Therefore, 2/5 is equal to 0.4 or 4/10 in decimal form. Let us have another example. Express 3/8 into decimal form. Again, using long division, we are going to divide the numerator by the denominator. That means 3 divided by 8. Since the dividend has a smaller value than the divisor, we are going to put a decimal point after 3 and right above it to preserve its original value. Then, annex or write 0 after the decimal point. So now, we can assume that the dividend is 30. We now have 30 divided by 8 is 3. Then, 3 times 8 is 24. 30 minus 24 is 6. Annex another 0, then bring down. That gives us 60 divided by 8 is 7. 7 times 8 is 56. 60 minus 56 is 4. Annex one more 0, then bring down. That gives us 40 divided by 8 is 5. 5 times 8 is 40. And 40 minus 40 is 0. Which leaves us again with a remainder of 0. Again, since there is no number written in the units place, we are going to write 0. Therefore, 3/8 is equal to 0.375 or 375 thousandths in decimal form. Are you getting familiar in the process? Great! For the previous examples, all answers are exact with a 0 remainder. What if it is not exact? Let us see this example. This time, let us try to express 4/9 into decimal form. Again, by using long division, we are going to divide the numerator by the denominator. That means 4 divided by 9. Put a decimal point after 4 and right above it to preserve its original value, then annex or write 0 after the decimal point. So now we have 40. 40 divided by 9 is 4. 4 times 9 is 36. 40 minus 36 is 4. Annex or write another 0, then bring down. So now we have 40. 40 divided by 9 is 4. 4 times 9 is 36. 40 minus 36 is 4. Let us annex one more 0 and bring down. So again, we have 40. 40 divided by 9 is again 4. 4 times 9 is 36. 40 minus 36 is again 4. And if we annex another 0, it will be 40 again. Can you notice a pattern this time? Correct! If we continue writing zeros, it will just repeat the same answers. And since there is no number written in the units place, we are going to write 0, which leaves us with 0.444 and write 3 dots after, which means that it just continues infinitely. Or we can write it as 0.4 with a bar called vinculum above 4, which also means that the number just repeats itself infinitely. These decimals are called repeating decimals. Thus, the final answer will be 4/9 is equal to 0.444 with 3 dots or 0.4 with vinculum. I guess this time, you are very much familiar on how to convert fractions to decimals using long division. That is, by dividing the numerator by the denominator. So that is how we convert fractions to decimals. Is it simple? I know you can do it. Then, how about trying it the other way around? This time, let us try changing decimals to fraction. Express 0.4 to fraction form. This is read as 4/10. Let us place it on the place value table. The number part is the number before the decimal point, and the fractional part is the number after the decimal point. We write 0 in the ones place and 4 in the tenths place. This can be written as 4/10 or 4/10. Of course, in changing decimals to fractions, we have to make sure that we express our answers in lowest terms. Then, if we have 4/10, to get its lowest term, you have to think of a number that you can divide to 10 and 4 without a remainder. What could be that number? Correct. It is 2. So, dividing 4 by 2 will give us 2. And dividing 10 by 2 will give us 5. So, the lowest term of 4/10 is 2/5. Therefore, 0.4 or 4/10 is equal to 2/5 in fraction form. This time, let us have an example with a number part greater than 0. Let us express 1.375 in fraction form. This is read as 1 and 375 thousandths. Placing it on the place value table, we will have 1 on the ones place and 375 on the fractional part. Then, we will have 1 plus the fractional part, which will be 375 on the numerator, and thousands, its place value as the denominator. Again, we need to get the lowest term of 375 over 1,000. In getting the lowest term, other than dividing it by a number, we can also find a common factor of the numerator and the denominator. In this case, both 375 and 1,000 has a factor of 125. 375 factored out as 3 times 125, and 1,000 can be factored out as 8 times 125. 125 on the numerator and 125 on the denominator, when divided, will just be equal to 1. So, what will remain is 3 over 8. Therefore, 1.375 is equal to 1 plus 3 over 8, or simply 1 and 3/8. So once again, to change decimals to fractions, we just write the fractional part on the numerator and its place value on the denominator, then get its lowest term. How about if the decimal that we need to change is a repeating decimal? Let us take a look at this example. We have to express 0.444 repeating as a fraction. In this case, we have to make an assumption. Listen very carefully. We are going to let n be equal to the repeating decimal, which is 0.444. Then, we multiply both sides of the equation by 10. Why 10? Actually, it could be 100, 1,000, or any powers of 10. As long as what you multiply to the left side of the equation will also be multiplied to the right side of the equation, it will be okay. But it will just result to a larger number, and it will be hard to simplify or get the lowest term later on. So, we use 10 to make it result to smaller numbers. So, multiplying both sides by n, we will have n times 10 is 10n, and 0.444 repeating times 10 is 4.444 repeating. Still, we have the repeating decimal 4.444. But 4.444 repeating is just the same as 4 plus 0.444, right? And 0.444 repeating is actually equal to n. So, if we subtract n to both sides of the equation, we will have 10n minus n is 9n, and 4 plus n minus n is 4. So, if 9n is equal to 4, then dividing both sides of the equation by 9, we will have 4 over 9. Therefore, 0.444 repeating is equal to 4 over 9 or 4/9 in fraction form. And that is how we express fraction form to decimal form and vice versa. I really hope that you learned something about our lesson today. So, before we conclude this topic, let us answer some practice questions to better understand this lesson. All you have to do is to find the equivalent value of each fraction to decimal and vice versa. Are you ready? Let us start. For the first one, what is the decimal form of 5/8? First circle, you have 0.635, triangle, 0.625, and for square, 0.615. Is it circle, triangle, or square? The correct answer is triangle, 0.625. Next, what is the decimal form of 7/9? For circle, you have 0.777 repeating. For triangle, you have 0.888 repeating. And for square, you have 0.999 repeating. Is it circle, triangle, or square? The correct answer is circle, 0.777 repeating. This time, let us have the decimal form of 1/2. For circle, you have 0.5. For triangle, 0.6. For square, 0.7. Is it circle, triangle, or square? Of course, the correct answer is circle, 0.5. For the next one, what is the fraction form of 0.35? For circle, 7/10. For triangle, 7/15. For square, 7/20. Is it circle, triangle, or square? The correct answer is square, 7/20. For the last one, what is the fraction form of 0.125? For circle, you have 1/7. Triangle, 1/8. Square, 1/9. Is it circle, triangle, or square? The correct answer is triangle, 1/8. I hope you got the answers correctly. That concludes another lesson for this morning. For your assignment, answer pages 19 and 22 of your learning modules. From our discussion today, we realized that there are things in this world that may appear differently but are actually the same. Just like in mathematics, there are numbers that are written in different forms, but their values are equal. That will be all for lesson 4. I really hope that you learned a lot from our discussion today. And I hope to see you next week. Enjoy learning!